Hi everyone, it's Coach Fred here, and today I was working with several students from schools around the country, and it really occurred to me that you're getting ready, you're working on factoring in your Algebra 2 class most likely, or you're just getting started on it, and they're assuming you know all this stuff and remember it from 2 years ago, which is always challenging. And then you throw in the fact that 2 years ago, many schools were doing so many different things because of COVID. That you might not remember really what to do. So this is a review of factoring polynomials. This might not be the way you've taught it, but I thought this might be helpful to some of you, so I'm throwing it up here on YouTube. So when I talk about factoring, I want you to recognize that you're dealing with expressions. So expressions are not going to have equal signs. They're not going to be in the form f of x or y equals. They're not going to have equal signs. And so we simplify expressions. But when they're polynomials, one way to simplify them is by factoring. But when I factor, I really go through a checklist every single time. And this checklist is kind of like my toolbox. It helps me kind of get through and remember things to do. Because it's a lot. I mean, it is a lot, okay? So we're going to go through just the basics, and these are going to be some basic problems, okay? So the first thing I always do is I look to see if there's a GCF, and I factor out the GCF. In my class, we might say GCF it. Everyone laughs when I say that, but you really want to do that always first when you're looking at a polynomial that asks you to simplify. A GCF could be a number like 2, so maybe something like this. I could give you, I don't know, something so basic, 2x squared plus 6x. How about just plus 6? So it could just be 2. Actually, let me switch to black because so I could factor out a 2 and I'd be left with the x squared plus 3. It could be a variable, so I could give you x cubed plus x, where I'd have to factor out an x. And it could be both, so I could give you 2x squared plus 6x, and I'd have to factor out a 2x. Something like that. So that's factoring out a GCF, and that's the most basic factoring that you do. Okay, so that's the most basic. But then after we've done that, there could be something that is left to be done. So the next step in our list would be to count the number of terms you have. Right now in Algebra 2, you're going to be looking at polynomials that have 2 terms, they have 3 terms, and they have 4 terms. All right, so let's start with 2 terms. 2 terms, if it's 2 terms, you really want to be thinking about this. You want to ask yourself, could it be the difference of 2 squares? The factor pattern. The difference of 2 squares. I call that dots. So you're going to hear me say that a lot. Is it dots? Is it dots? Dots looks like this. It's 2 terms, both of which are perfect squares, 2 terms, both of which are perfect squares, and it's a difference. Difference means subtract. So when we have x squared minus 25, we could factor it using the pattern. The pattern is x plus 5, x minus 5. The way the pattern works, and I'm not teaching the pattern, I'm reviewing the pattern. The way the pattern works really is that it's the square root of each term, right? 1 plus 1 minus. Well, why is that? Truly because if you were to multiply these 2 binomials out, you'd get a 5x and a negative 5x, which would cancel, which makes the middle term kind of go away, okay? So if there's 2 terms, I'm going to look for dots. Be careful. One of the things you could get in the way is that it's not dots. It's like x squared plus 25, and that's actually not factorable. So beware of the plus sign with 2 terms. All right, the other thing you could be dealing with 2 terms, if you learned it, would be the sum and difference, sum and or difference of cubes. Of cubes. Okay, so I call that socks and docs. Coach Fred loves to do that. Okay, so what does that mean? Well, socks and docs, sum and difference of cubes is a factor pattern. So, for example, if you were given x cubed plus y cubed, that would factor into x plus y, x squared minus xy plus y squared. And if you were given x cubed minus y cubed, that would factor to x minus y, x squared plus xy plus y squared. The one thing that can kind of get confusing for kids is the signs. So I always like to use the mnemonic SOAP to help me. This first term here is going to have the same side as the original. This one's going to be the opposite of the original, and this one's always going to be positive. So same sign, opposite sign, always positive. Works for minus as well. Same sign, opposite sign, always positive. All right, so how do we work with that? All right, so let's look at it. I'll give you something like, I don't know, how about 8x cubed plus 1? I can see, number one, there's no GCF, because that's what I would do first. Then I count the terms. It's got 2. Is it dots? Not dots, because it's not perfect squares and it's not subtraction. So looking at it, are they all cubes? And they are. So it's the sum of cubes. All right, so what do I do? This is not the way everybody does it, but this is the way I do it. The first thing I like to do is, because I know these patterns so well, is I like to rewrite. Again, I like to rewrite everything as a cube. So that would give me 2x cubed plus 1 cubed. All right, why? Well, because then 2x is my x and 1 is my y. So when I plug it right into the formula, I'm going to get 2x plus 1. Now you got to be careful here, because now I've got 2x, but I have to square it. I have to square the whole quantity. So that would be 4x squared minus 2x plus 1 squared, which is 1. Okay? All right, so that's a quick review of dots and the sum and difference of cubes. The same pattern would apply to minus. You just have to use the factor pattern. All right, moving on. What happens when we have 3 terms? 3 terms, oh goodness. That gets trickier, because there's a lot that could happen. 3 terms, the first thing I do, no matter what, is I look for a perfect square trinomial. So I look for a PST, a perfect square trinomial. So here's an example. A perfect square trinomial is when the first and last terms are perfect squares. And if you were to take their square roots, the middle term, disregarding the sign, is the product of those two times 2. Let me say that again. The first term and the last term are perfect squares. Oh, one thing I almost forgot. The last term is always positive. And if you take the square root of the first term and the square root of the second term, which I wrote right above it, you multiply them, and you multiply them by 2, and that number works, then it is a perfect square trinomial. Why is that nice? Well, a perfect square trinomial means that it can be written as the square of a binomial. That means 2 binomials that are exactly the same. So in this case, the square root of the first term, the sine of the middle term, and the square root of the last term. All right, so perfect square trinomials, I do have a video on that, so if you need more practice on it, go check it out, okay? All right, then, again, GCF'd it, counted the terms, 3 terms. It's not a perfect square trinomial. Then I look at the A term. And so when I say that, I mean, if it's in the form ax squared plus bx plus c, I look at the value in front of the x squared, the constant or the coefficient in front of x squared. All right, so if A is 1, something like this. All right, then I know I'm going to be using what I like to refer to as the AM method. Now, I know there's a lot of different ways that teachers teach it. I like to use guess and check with factoring because I think it builds a lot of number sense. That's my thinking, but I don't think any of the other ways are wrong. So the AM method means that I'm looking for the things that multiply to 15 and add to 2. All right, so I make my 2 binomials. The first term, since it's A is 1, is going to be x and x because x times x gives me x squared. Now remember, we're breaking it up by factoring, so we're breaking it up into the 2 things we multiply that would give us x squared plus 2x minus 15. All right, I write down all my factors of 15, so 1 and 15, and 3 and 5. All right, now I have to figure out which sets of factors could I get to add to a positive 2 and multiply to a negative 15. Well, if I make the 3 negative and the 5 positive, and I add them together, I would get a positive 2. If I multiply them, I'd get a negative 15. So those are the factors I'm going to work with. So my factors would be x minus 3, x plus 5. Now, if you've watched my video on factoring when a is 1, you'll know that lots of teachers teach this method of multiplying called FOIL. I tend not to do that because it only works with trinomials and binomials. But if you are thinking about foiling or multiplying the two binomials, the ones that are really the hardest for kids is the O and the I if you have to multiply it back out. So the O and the I come from here and here, the inners and the outers. So if I multiply the inners right below it and I multiply the outers, I can see really quickly if I add them, I'm trying to get the middle term. It's a way to check, especially when we move on to this last method, which is when a is greater than 1. Okay, so when a is greater than 1, maybe something like this. Let me change to a different color. 15x squared minus 16x plus 4. This one's a little bit harder. Now let me move this. Give myself some room here. Okay, so I have to look at the factors of not just 16 and 4, but I have to do MAM. So I have to look at the factors of 15 and the factors of 4. So I've got 1 and 15, and I've got 5 and 3, and I've got 4 and 1, and I've got 2 and 2. I tend to work with the ones that are more commonly seen, so I'm going to start with 5 and 3. So that would give me 5x and 3x. At that point, I immediately put in my little connector. I call them connectors because they kind of help me see the numbers together. So I have to pick factors from this set in such a way that that when I multiply the inners and the outers, I'm going to get negative 16. All right, so again, if I work with the numbers that I'm most commonly used to seeing, I'm going to go with 2 and 2. All right, notice I didn't put any signs in. Well, I'm going to multiply these out and see what I get. I get a 10x on the outside. I get a 6x in the inside. In order for those to multiply and add to negative 16, they both need to be negative. So there are my factors. Another hint, if this is negative and this is positive, there's only one way that things can multiply to a positive and add to a negative. They both have to be negative. Okay, that's the 3 terms. Now we got to move on to 4 terms. 4 terms are a little harder. So 4 terms is when we're going to have to factor by grouping. All right, so we've checked for a GCF. Now we're at 4 terms. We're going to factor by grouping. So here you've got something that's got 4 terms. But before we do that, I think we need to review. Here I have a polynomial that has multiplication here and multiplication here. And so to be good at factoring by grouping, you have to recognize that this y minus 3 is actually a GCF in this term and in this term. So it can be factored out, leaving you with x plus 2. I really don't love it when students learn it that you take one of the y minus 3s and keep the x plus 2. I don't think that's making you understand that what you're doing is you're actually factoring out a GCF that's an expression. So we have to be good at recognizing that to be good at grouping. All right, so here I've got 4 terms, and what I do is I put them into groups. Now, the order of the groups doesn't matter, but I'm just going to go left to right because I can see it works nicely. So I take out the greatest common factor of the first group, which would be Q. I'd be left with P minus 2. The greatest common factor of the second group is 2, and I'm going to take that out. But when you take it out, always put a sign in front of it because sometimes you're going to be taking out a negative, sometimes a positive. That's going to leave you with P minus 2. If these binomials are the same, then you've grouped it correctly. If not, you have to go back and check and do something different. All right, so now P minus 2 has become a GCF because in this term and this term, this term, it's common. So I pull out P minus 2 and I'm left with Q plus 2. All right, let's look at a little bit harder one. Here we've got this polynomial. It's got 4 terms. There's no GCF of all the terms, so I have to factor by grouping. All right, I'm going to group together and see what we got here. All right, in the first group, it looks like I don't have a greatest common factor. And that's because I wrote it wrong. So let's rewrite this. X cubed minus x squared minus 4x plus 4. All right, so in the first set of numbers, I've got a greatest common factor of x squared. That's going to leave me with x minus 1. In the other group, I have a greatest common factor of 4, but I need it to get an x minus 1, so I actually have to take out a negative 4. So when I do that, I'm left with x minus 1. All right, my binomials are the same, x minus 1 and x minus 1, so that's my greatest common factor. And I'm left with x squared minus 4. But the last step that I didn't talk about is when you look at your final answer, you want to make sure you've factored it completely. So that should be our final step. Factor completely. Because if you look here, this actually can be factored more because it's dots. 2 terms, perfect squares, difference. So you can factor this into x minus 1, x plus 2, x minus 2. All right, so that's my quick review of factoring. I'm sure I missed something, but I'm hoping this helps anyone that chooses to watch it, okay? Have a great day, guys.